Same mirror board.
Okay, mirror board.
Find it.
I'll bring you to me.
Let's
Oh,
go.
open it. It should say, is that what, oh yeah, it's called Stacy Get Your Life. It's called Kylie, Stacy Get Your Life Together. It's called. All right, I opened the wrong board. Okay. X when X is less than or equal to -3. -2. I probably shouldn't have erased that one on the board because I could have referenced it, but it's okay. All right, so here's what we're going to do with plug-in method. You know we're being cut off where? What X values are cut off? -3, right? We'll come check on you in a minute if you're not back. All right, we're going to take the cutoff part and we're going to plug it in. If you plug that in, so I start with -3, what do I get out? This is an easy question. It's not a trick. -3. Y is X, right? -3. Because that's my cutoff point. That's where if I was graphing it and I've got this line, that's where I'm cutting it off, right? I want to know where that cutoff is. Yes. Nope, there's a new way. Where did -3 come from? Look at.
Okay, you want me to do?
Yes, please.
No.
Okay. This number right here is -3, yes? That's where I pulled -3 from. Where did I get the second one? You plug this into the equation. What's the equation? The equation is y equals x.
It makes sense.
Okay. All right, let me ask you this. When I cut it off at -3, is it a solid dot or an open dot? How do you know? Okay. Now, read this inequality to me. X is less than or equal to -3. Give me a number, any number, but preferably close to, that is less than or equal to -3. -4. I heard -4. Agree wholeheartedly. That's the one I would choose. Okay. Anything, but it needs to meet the requirements here. So it needs to be less than -3, right? So let's do -4. If I plug -4 into this equation, what do I get out? I'm going to plot that point as well. So -4, -4. Remember, I'm showing you. Remember, the first point I plotted was my cutoff. As long as it's less than or equal to -3. Okay. The equation's y equals x. So if you plug in -4, you get -4. If I plug in 20, I get 20. If I plug in 2, I get 2. It's erasing. Some people can't see. A lot of times if we don't do that first, you don't realize that you've got two pieces of actual lines. They're not just raised. They're actual lines. We've just taken part of them off. And we'll use that. We'll kind of build on that a little later. All right. Yeah. Because that is this equation. We are graphing. This is number 3 on your homework sheet. Yeah. Because it's y equals x. I'm fixing to show you another instance of what happens. Okay. Oh, that's fine. What? Okay, so let's move to the second part so you can see because it's a little different. All right, so the second equation is y equals negative 2x plus 1. If I was graphing that like Ms. Lopez was talking about that we did yesterday, I'd start at 1, I'd go down 2 over 1, connect them, and then I'd cut it off and I'd erase, right? That's what we did yesterday. But today we're doing a little bit neater method. So we're going to do the same thing. We're going to take this and we're going to plug it into this equation. So I plug in negative 3, and if I plug negative 3 in, I get negative 2 times negative 3 plus 1, which is 6 plus 1, which is 7. This is my cutoff point. This is where that line is drawn, right? So negative 3, oh, dear Stacy, up to 7. 1, 2, 3, 4, 5, 6, 7. And I need this time an open dot, right? An open dot because there's no line under it. Now, okay, not negative 4 this time because look at it again. It's got to be pick an x that's bigger than negative 3. Negative 2, I love it. Negative 2. If you plug negative 2 into that equation, you get 5 back out. So negative 2, 5, and this is the way it goes. The only one that's open is your end. The only one that has the potential to be open is the end one. The cutoff. Did everybody hear that? My pre-cal kids were asking that the other day because we're going to get to where we're doing piecewise with quadratics and everything else. The only point that has the potential of being open is the point where it's cut off. Yeah. I'm listening, Max. The only point that has the potential of being open is the point where it's cut off. So anything on the rest of the line is closed. This is what happens second one. I would say the same thing 5 times and people would ask the same question. It's what? Amazing? It's not confusing. Okay, look at it. Look at the graph. What is the domain? Domain is left to right. What's the range? Yes. Bracket or parenthesis on 7? Parentheses. The range from the bottom up. What's the, no, from the lowest, and then you go up until you can't anymore. There's no graph. That's correct. You have to look at both of them together as one big graph. Okay. Okay. It could be.
What would that, what
That would be right. I haven't done this.
If you had something that did this, this would be the range here would be negative infinity, but it stops right here. We'll call, let's say this is negative 1, let's say this is 2. It stops at negative 1, it can be negative 1, but then where does it pick back up? 2. And it goes up forever. U is whenever I join two pieces together. You union them. That's exactly right. It didn't join anything. It was just one continuous range. There weren't any holes or places where it didn't have any graph. That's because on the 7 on that one, it was open. Yes. Okay.
Infinity is always parentheses, right?
Yes. Okay, let me show you one that's got 3 pieces. Jonathan, I hadn't heard nothing from you, buddy. You okay? You're boycotting my class? This is number 8 on the back. This is only going to leave you 3 for homework. 1, 2, 3, 4 for homework, plus to finish and to turn everything in. But I'm going to do this one with you because I want you to see what happens when you got 3 pieces instead of 2. Okay. Okay. If you can do a 3, you can do a 2. So, yeah, what you got? That means it's always that number no matter what you plug in for X. It's a horizontal line. All right. So let's start. Now here's what you need to remember, or here's what you need to know. If I've got a line, any line in the whole world, it doesn't matter, and I'm going between 2 numbers, that just means that it's going to look like this with just this middle piece, and you're not going to have, it's going to be bounded here, okay? Do you see the difference? It doesn't go off forever in one direction. That's kind of what we're going to be looking at whenever we see.
Leah, go away.
So that would be 24, but that's fine because you don't have to always square it. So 24. It was a trick question. Because you can't take those odds. Right. So that's why you have to compare it. So I don't think left out every left out. Only thing it does is you got it, silly dude. Yes. All right. What? I thought you had one. Oh, that really was yours? You didn't take one home? The first, 2, 1 and 2. Yeah. All right. Right. We're turning it all in tonight or tomorrow. All right. I'm going to plug in 0 first because that is my restriction there. When you plug it in, what do you get? Come on, y'all. 0. 0. That's right. 0, 0. That's where you start. Yes, and that's what you plug in. Is it open or closed? Is it open or closed? Why? Why, Sawyer? That is correct. Now, I need an X That is less than 0. If you plug -1 in, what? 3. Negative. Yes or no?
Yes.
That's the first piece in our 3 piece. Okay? Piece number 2. You're using that equation, -3x, and you're plugging in these values. Now I'm going to plug in this equation, but this time I've got 2 endpoints, okay? So be careful. The first one I'm going to plug in is 0. If you plug 0 in here, what do you get? No. In between, yeah. -1, because that's correct. Let me plot this one first. 0, -1. Is 0, -1 open or is it closed? Closed. How do you know? It's or equal to. Now plug in. Tell him again, Sawyer. 6. Plug in 6. He's very excited about plugging in 6. What'd you get? -4. All right, 6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Open or closed? Open. Why is this one open? There's no line under this one, right? All right. Connect them. No arrow on this because it's smushed between just 2 numbers. It doesn't go on forever. This is a line segment. Central part, line segment.
Yeah.
Oh, Grace, I don't even want to relive it. All right, let's look at the last one. What am I plugging in? 6. What do I get? Now, open or closed?
Open.
Oh, this is interesting. Okay.
Wait. 0.
You can pick whatever you want as long as it's bigger than 6.
Why does 7 not work?
It does. They said, can we pick something else?
Hey, why is it 7 0? What is that plugging in? Because we did 7 the second point on 0. We always do 7 the second. Why is it?
Okay, wait. 1 second. Oh, yes. The only one that has the potential to be open is on a cutoff. Okay. It'll say that one more time.
Yeah, but it has to be a cutoff number.
To be cut up like that, yes. Okay. All right, here's the tricky part of this one, so y'all pay attention. This is going to be the hard part. Are y'all ready? Y'all are going to do fine. The domain and range on this one. Now, I really want you to look at this before you answer, okay? I'm going to slide this out of the way, and I'm going to look at domain and range. For the domain, from left to right,
It's left to right, it's not the range.
you're close. It's to 7. Why are you stopping at 7? Look at what happens at this point. All right, look, because this is where it gets confusing. Normally, one of these would be filled in, right? But look, neither one of those is filled in, which means my graph is never 7. No matter what happens, x can never be 7. Why can't x be 7? What in the world? That should be 6. That should be 6, not 7. That should be 6. Dang, y'all. Give me a heart. Everybody say, ah. Okay. 6. Look, here's why. Look over here. X can get up really close to 6. Can't be 6. X can get up really close to 6. It can't be 6.
We can always check our inequalities.
Huh? Right. Neither one of them have a line under it. Right.
What if people get close?
Then you would include it. But here we can't include it. So what I'm going to do, and this is where you need to make a note. This comes up all the time. If I need to leave out a single value in interval notation, we do it with a U. We do back-to-back parentheses with a U.
What if it was a close? Would it be infinity? Like if you're close.
Yes, it's only one of them.
We need to watch our
Yes. Okay.
But now with the range, -4
Okay, so the range. Let's look at the range for just a minute. Because the range is equally as confusing in my opinion. The bottom, the lowest it ever goes, and I always take my hand like this and look at it because it's easier for me to see. -4. Can it actually be -4 though? No. So I'm going to put a parenthesis. And now start going up. As I go up, okay, Riley Gray said I got stuck at -1. But there is actually a closed piece here, so I don't have to. Okay. Desi said I got stuck at 0. But is it? I don't know. It's right. Yes.
Did I do my graph right? What did I do? Just maybe explain.
Okay. From the bottom up, and if you get confused, I will generally take my pencil like this so I can see. So as I start going down here, right? This is my first, that's the lowest point. That's easy to find. We know that's -4, right? Can it actually be -4? No. That's why I got a parentheses. Okay? Now, as I go up, I want to stop every time my graph stops and I need to check it. So as I go up, my graph stops right here, right? So I look across, but here's the issue. While this graph stops, it's closed in, so it can be that value. And then up above it, this one goes up forever. So it will never be dotted in the middle of the line. Like, I can't make this one an open dot here.
What is the other perfect one?
What if, let's do this. Let's say this what if. All right, guys, pay attention. Hold on, no, look at it. Hold on. All right, what if I erased that part of the line and now this is my graph? How does my range change?
Wait, it doesn't.
It changes. Look at it carefully. I still start at -4. And now I go up to -1. It includes -1, yes? I changed it. I'm just changing this for the sake of an example. This is not the one on your homework. If I took this piece over here off and it was just these two pieces like this, what would my range be? Well, the lowest it goes is -4.
And then you do the other one, it'd be 0 to infinity. Yeah.
The only thing you said wrong was this one needs to be a bracket because it's on this. Not a parenthesis. We erased part of it just for the sake of example. I was just showing you.
That's not where the actual problem is. What if negative 1 was open?
What if -1? Then it would be a parenthesis.
What if it was the first graph we had before you erased it, but it was still open? So wait, I'm not this.
First graph. No, it would change. It would change. Hold on. If this were open now, if this, oops, this was open like that, is that what you're saying?
Yeah.
Then it would be -4, but I would have to stop at -1 and do a parenthesis and then a U from -1 to infinity. I have no idea what you
Okay,
said.
so if you're going from the bottom is left, the bottom is most bottom point. And if you're going up and you encounter a closed point and there's nothing on the line,
Then it's
above,
parentheses.
stop.
Yeah.
But and also if you come across 2 open points, it's the same thing.
Yeah.
So
It only takes one closed point to include.
what if it's 2 closed?
It still includes it.
Alright, and then if it's 2, and if it's a closed and an open, it's open.
I'm not sure what
If
you
there's a closed point and an open point on the same line, it just keeps going.
Well, this has got a close. This has got an open and a close. Well, right, because over here there's another one, and it keeps going up, so it goes up to infinity.
What if that other one was closed?
This was closed like that,
Yeah.
it would still go up to infinity. The only thing, open leaves out. That's a parenthesis.
If it stops at the same line, something begins, you don't have to put it in.
Say that again?
Like on this instance, if it stops and another one began on the same one.
You don't need a U.
Alright, we do number 4. Why would the domain be like that then? But the domain is the same exact thing.
Okay, but it's left to right. So as you move left to right, whenever I get right here, that's my first area that might be a problem. This one's closed in, this one's open. As long as one of them's closed in, I'm good to keep going. Keep going across. This is my next place where I hit a snag, but this one's closed in there, so I'm good to keep going.
So moving left, right, open has power, moving up and down, close has power. I'm so.
I think you're confusing yourself because you're trying to think of some little.
Can we do number 4? Maybe you'll get help. Can we do number 4?
I want to have some for y'all to try.
Can we do number 4? We can do 3.
Yeah, y'all have only got 4 to do, so I want you to try them on your own. Yeah.